Right now, you are looking at 400,000 architects vibrating. 14 hours ago, this forest floor was silent, cold, empty. What happened between dawn and this moment is one of the most extraordinary feats of collective engineering on Earth. This is the Pine Needle Kingdom. 5 a.m., 7:45 a.m. In the ancient Schwarzwald, Germany's Black Forest, there exists a kingdom so precise in its engineering that it rivals anything built by human hands. And yet, its architects weigh less than a grain of rice. It is 5 o'clock in the morning. The forest floor lies submerged in cold blue silence. Dew hangs from every pine needle like a jewel suspended in still air. The night shift is ending. A thin-legged wolf spider, Pardosa lugubris, crosses a lichen-covered stone on her final nocturnal patrol. An egg sac silk-bound beneath her abdomen. Carrying her unborn young reduces her hunting speed by 30%, yet increases offspring survival fivefold. Beneath peeling bark, a brown centipede coils into its daytime refuge. Lithobius forficatus possesses venomous forcipules, modified legs curving forward like twin syringes, capable of subduing prey 3 times its own mass. This body plan has persisted unchanged for 400 million years. In the shadow beneath a granite stone, a violet ground beetle retreats from dawn. Its purple sheen is structural coloration, microscopic ridges scattering light through thin film interference. Unlike pigment, it never fades. It is encoded in the geometry of the exoskeleton itself. But the true rulers are already stirring. From the tunnels of an enormous thatch mound, the first sentinels of a redwood ant colony emerge. Formica rufa. This is eusocial insect behavior at its most sophisticated. 400,000 individuals operating as one. Their mound is thatch mound thermal engineering, a solar collector where every needle is angled at 30 degrees to maximize thermal absorption. Research from Helsinki has measured internal temperatures reaching 28 degrees when the outside air sits at 12. Every centimeter of this forest floor is a macro documentary of survival. A common pillbug feeds on decomposing bark, not an insect, but an isopod crustacean breathing through gill-like pleopods. When threatened, it performs conglobation defense, turgite plates interlocking into an armored sphere no mandible can crack. In a dead spruce trunk, the bark beetle Ips, Typographus, barely 4 millimeters long, excavates a nuptial chamber in the phloem layer, releasing pheromones that summon females. Together, they carve egg galleries, radiating like wheel spokes, the beginning of phloem layer destruction that kills a mature spruce in weeks. At the base of a pine, firebugs gather. Their red and black markings are aposematic warning coloration, honest advertising that deters nearly every predator in this forest. 7:45 a.m., 11:30 a.m. By mid-morning, the forest floor hums with energy. A green tiger beetle, Cicindela campestris, crouches on bare, sandy soil, its metallic elytra blazing with iridescent copper. Tiger beetles are among the fastest-running insects on Earth relative to body size, clocking speeds of over 5 kilometers per hour, the equivalent of a human sprinting at 770 kilometers per hour. But this extraordinary speed comes at a neurological cost. Their visual processing cannot keep pace with their locomotion, producing a phenomenon researchers call green tiger beetle, sprint stop hunting. The beetle literally runs blind, forced to halt and reacquire its prey between each explosive burst. On the bark of a Scots pine, a jumping spider, Psittacus pubescens, watches through 4 enormous forward-facing eyes that grant binocular vision with a resolving power of approximately 11 minutes of arc, rivaling that of a cat. When it leaps, it does not use muscles alone. Spiders lack extensor muscles in their legs entirely. Instead, the jumping spider employs hydraulic hemolymph jumping, pressurizing its body cavity with hemolymph fluid at up to 60 millimeters of mercury, catapulting itself up to 50 times its own body length, trailing a silk dragline as a safety rope. A marmalade hoverfly hovers at a bilberry flower, its orange and black abdomen a near-perfect imitation of a wasp. This is Batesian mimicry, a harmless species borrowing the warning colors of a dangerous one. Studies from Oxford have shown that even experienced avian predators avoid hoverflies at rates exceeding 80%. Along established foraging trails, the redwood ant colony operates at peak throughput. Workers stream outward carrying chemical trail pheromones and return bearing caterpillars, dead flies, and aphids. Some ants tend root aphid colonies on exposed spruce rootlets, stroking the tiny insects to stimulate honeydew excretion trophobiosis, millions of years in the making. On the trails, returning workers exchange liquid food mouth-to-mouth trophallaxis, distributing nutrition across the colony so efficiently that a single sugar source reaches every member within 72 hours. A European hornet Vespa crabrow lands on dead spruce bark. She is the apex aerial predator of this floor. Her mandibles scrape bark fibers into a cellulose pulp ball she will carry back and chew into paper. As late morning approaches, the firebug aggregation swells to 20 individuals, a collective amplification of the aposematic signal that deters even the most persistent hunter. "11:30 a.m., 14:30 p.m. The midday hours bring a profound stillness. The flat white overcast light eliminates every shadow, and the world falls quiet. Beneath a fallen log, the forest's most spectacular resident waits in torpor. The European stag beetle Lucanus cervus is the largest beetle on the continent. Males can reach 75 millimeters. Their enormous branching mandibles evolved not for feeding, but for combat. These are sexually selected mandibles, weapons shaped across millions of years by the relentless pressure of reproductive competition. Research published in the Journal of Evolutionary Biology has demonstrated that mandible length in Lucanus cervus correlates directly with mating success, with males in the upper 20th percentile securing over 60% of all observed copulations. The larvae that produce these magnificent adults develop inside decaying wood for 3 to 7 years, feeding on cellulose broken down by symbiotic gut fungi of the genus Odontotaenius. Every rotting log in this forest is a potential nursery, and every log exists because a bark beetle killed the tree that fell. On the dead spruce trunk, fallen bark reveals the full artistry of the bark beetle gallery system, a central nuptial chamber from which maternal tunnels radiate outward, each lined with egg niches, larval galleries branching perpendicular, widening as the larvae grew. Patches of blue-green fungal staining surround the gallery's ophiostoma, a symbiotic fungus carried by Ips typographus and inoculated into the tree during colonization. The fungus disables the spruce's resin defenses and accelerates phloem layer destruction, providing additional nutrition for developing larvae. It is a partnership of devastation refined across evolutionary time. In damp crevices between granite stones, pillbugs cluster together, conserving moisture for their respiratory pleopods. On the ant mound, activity has slowed but not ceased. Workers bask on the warm thatch in flat postures, absorbing heat into their dark exoskeletons. Others vibrate thoracic muscles at ventilation openings, living fans regulating the atmosphere of brood chambers below. Inside those chambers, nurse ants tend white pupae in warm, amber-lit spaces, repositioning the developing brood with surgical precision. On living spruce bark, fresh resin oozes from a wound, a golden amber sphere that is both defense and trap. A tiny fly lies embedded, wings frozen. This is the living process of amber creation, the same mechanism that preserved arthropods in Baltic amber 40 million years ago, happening right now on this trunk. 14:30 p.m., 17:15 p.m. In the warm afternoon, the colony reveals its most astonishing secret. Redwood ants do not merely collect warmth, they carry it inside. Workers bask on the south-facing slope, pressing dark exoskeletons flat against the warm thatch, absorbing thermal energy until their body temperature rises several degrees above the surrounding air. Then, they descend into the brood chambers and press their warm bodies directly against the developing pupae. They are living hot water bottles, a thermogenic conveyor belt operated by thousands in perfect coordination. The brood chambers hold a stable 26 to 30 degrees Celsius, even on cool, overcast days. No thermostat, no wiring, only the collective intelligence of 400,000 minds, weighing less than a sugar cube combined. The 30-degree needle orientation traps warmth in insulating air pockets. Resin droplets on individual needles act as microscopic thermal masses. The entire mound is a passive solar heating system of extraordinary sophistication. A European hornet powers through the understory on its final hunting patrol. Vespa crabrow captures a hoverfly in mid-air, mandibles closing on the prey's neck in a fraction of a second, then lands on a bilberry stem and methodically butchers the catch. Wings and legs are discarded. The protein-rich flight muscles are compressed into a compact ball and carried back to the nest, where hornet larvae will consume the offering and, in return, secrete a nutritious saliva that feeds the adult workers. It is a closed economy of protein and sugar, perfectly balanced. As the afternoon cools, the firebug aggregation tightens. Peripheral bugs walk toward the center of the cluster, compressing the mass, sharing body heat. On the mound, the thermal cycling intensifies ants, rising and descending with increasing urgency as the available warmth diminishes. Sentinels take up positions at every tunnel entrance, mandibles open, gasters raised. The colony is shifting from industry to vigilance. And beneath the fallen log, a single massive mandible slowly extends from the darkness. The stag beetle stirs. (15 p.m., 19 p.m.) As twilight descends, the stag beetle emerges fully. He climbs the mossy log and stands on the crest with his mandibles raised against the fading sky, a silhouette from another age, a prehistoric warrior crowned with antlers of chitin. His lamellate antennae splay open, their fan-shaped clubs covered in thousands of olfactory sensilla, sampling the pheromone-laden evening air for the scent of a female. A challenger approaches from below. The two males lock mandibles and wrestle on the moss-covered crest, the dominant male leveraging his superior size to lift the rival from the surface and push him toward the edge. This is the combat that shaped those extraordinary weapons across millions of years of sexual selection. The strongest genes pass forward, the fallen walk away. In the gathering darkness, the night shift awakens. The wolf spider reemerges from her silk-lined burrow, her eyes catching the last photons as green-silver pinpricks of reflected light. The eye shine unique to lycosid spiders, produced by a reflective tapetum behind the retina that doubles the light available to each photoreceptor. The centipede unfurls from its bark crevice, all 15 pairs of legs rippling in coordinated wave patterns as it flows headfirst down the log toward the forest floor, forcipools spread wide and ready. The violet ground beetle emerges at last, its structural color flashing one final iridescent violet before the light fails entirely. It seizes a slug on the damp needle litter, mandibles sinking into the pale flesh nocturnal predation in the near darkness. And on the mound, something extraordinary begins. As the temperature plunges, hundreds of thousands of redwood ants pour from every tunnel entrance and converge on the surface. They do not bask now, they cluster. They pack together in dense interlocking formations, body pressed against body, legs intertwined, and they begin to shiver, not from cold, but with purpose. Each ant vibrates its thoracic flight muscles at high frequency, shivering thermogenesis, generating metabolic heat from within. The collective warmth of the formation is measurable, the mound humming with a deep organic drone like a biological engine. The outer layer of ants endures the cold, rotating periodically with warmer individuals from below, distributing the sacrifice across the colony. Beneath this living blanket, the brood chambers remain warm. The pupae develop. The next generation grows. A wolf spider watches from a distance but does not approach. The formic acid barrier and the sheer density of the formation are impassable. The pine needle kingdom has sealed itself for the night. You are standing on the most precisely engineered structure in this entire forest, and its architects weigh less than a grain of rice. They will hold this formation until dawn. They have done so every night for longer than any human civilization has existed. And when the blue light returns to the Schwarzwald floor, the sentinels will emerge again, antennae raised, testing the cold air. The kingdom endures. The pine needle kingdom will hold its formation until dawn. But 60 kilometers south, on the banks of a black forest stream, another kingdom faces a very different kind of night. The water is rising, and the architects who built their world at the water's edge have nowhere to retreat.